Good afternoon, everyone. Happy Sunday. And we are here today to do our test review for equations and fractions. First, what I'm going to do is I'll go over the notes really quick, and I'll let you know where you can go to access these notes. Second, we will go over all of the problems in the test review that was given to you last week. And if you have any questions during the course of this test review, you can always chat with me on YouTube. If you have your Garland ISD login, remember you can log into Google Classroom and chat with me there. Um, Otherwise, you can always ask me when you see me in class tomorrow. So let's go ahead and get started. We want to just go over really quick the things that we highlighted in our notes. Anytime you get a word problem, just make sure that you can build both an equation and a strip diagram from it. Both of these should reflect each other and they should show the same information. So if you need help with, um, if you need help with how to show addition and subtraction problems, that starts on page 72 in my notes. And then if you need help with multiplication and division problems, that begins on page 75. And so we went through how to show both addition and subtraction and then multiplication and division problems using strip diagrams. So definitely we want to look over that. Following writing equations, the next thing you should be able to do is look at input-output tables and write an equation that comes from the data in the table. You should be able to go in both directions, going from one piece of the data to the next, and then how to go back as well. And that's just simply using the opposite operation in order to go back the other way. But the most important piece that I told you to highlight was seeing it in an input-output machine kind of format as well, because they're not always in a table form. So as long as you can see that whatever is going in, something is happening to it in order to get this number that came out. And you can write an equation based on the information that you inferred from here as well. But there's not very much on this upcoming test on equations. It's just very simply, can you write an equation from a problem? And then can you see what's happening in either a function machine or an input-output table? But the largest portion of the test is going to be over fractions. And so in our fractions unit, definitely know what unit fractions are. That's just one piece of the whole. Unit means one. And so when we're looking at unit fractions, that has a 1 in the numerator. That means it's just one shaded piece of all of the pieces that are there. And we use unit fractions to decompose fractions like 3/5 or 3/6 or 2/4 into a sum of its smaller pieces. And we'll get back to this again later. The next one is, this one is a big one, knowing how to find equivalent fractions and knowing knowing how to identify that two fractions are equivalent to each other. Remember Mama Peach's world famous peach pie. Just because I only give one piece from this pie doesn't mean I'm giving the same portion as this pie over here. So when we're talking about equivalent fractions, we want to make sure that we're giving a fraction that is the same portion of the whole. So we're not counting the number of pieces. We want to see how proportionate it is. And as long as we're giving the same portion of the whole, we're giving equivalent fractions. I have to apologize about the poor quality of this video. There's something wrong with the focus, and I have been trying to play with it for the past hour, and this is the best that it can get. So I apologize if it's a little bit hard to read, but I think, like from where I am, I can mostly read what's going on here. And if there's anything that's unclear, I'll try to point it out to you. This process chart right here on page 89 is probably going to be one of your best friends. You've got to be able to use multiplication and division to find an equivalent fraction. And so following these two steps, you've got to use an equivalent to 1, which means any fraction that has the same numerator and denominator, so that you're not changing the value of the fraction at all. Okay, we invoked the principle of the identity property, meaning we're not changing the value of the original fraction, we're just changing the number of pieces in proportion to the whole. So multiplication is definitely a lot easier than division because you can multiply any number by a number that you choose. But as far as division goes, not everything can be divided evenly by any number that you choose. So as far as division goes, when we get to simplifying fractions, you have to know the factors of both the numerator and the denominator so that you can pick the factor that's the same. That way, you're still doing the same math on top and on bottom. You're still using an equivalent of 1 to divide. And so as long as you're still using an equivalent of 1, same math on top and bottom, then you have an equivalent fraction. Following that, the next thing you need to be able to do is to compare fractions. So we know how to find equivalent fractions, but now we need to compare them. Which fraction covers more of the shaded region, covers more of the whole than the other one. And so we cannot just simply compare fractions by looking at the number of pieces that are shaded. If the total number of pieces of the whole are different, there's not really a good way to just simply look and compare because it's not fair. So we want to make sure that we're comparing the shaded region to each other, not just the number of pieces. Okay. Um, and so that's where we need to find common denominators in order to compare. So in all of these cases, we had to find common denominators. And this page right here, page 98, or wherever it is in your notebook, these guiding questions are going to be very important. First, you need to ask yourself, do you have common denominators? If you do have common denominators, you can just go ahead and compare. If you don't have common denominators, then you need to make them. Okay, so either by looking at least common multiple, or you can reduce fractions to make sure that you've got common denominators, and then you can go ahead and compare after that. Okay, and the last thing is adding and subtracting fractions. We're coming back to showing a fraction as a sum of its units. So if we have something like 3/4, we know what 3/4 looks like. So how can we show it as an addition problem as a sum of its units? So one of these pieces is 1/4 plus another fourth plus another fourth. That gives us a total of 3/4 being shaded. Okay, same goes with 5/8. You can show it as a sum of all the little individual pieces. And so along the same lines, you can decompose them in other ways. So if you wanted to use different fractions, so let's say we've got 5/9 here, we want to show it as a sum of smaller fractions. So 2/9, 2 of these, plus 3 of those, all together add up to be 5/9. And you should be able to show it in a picture form as well as using the addition problem. And I said finally, but there is one more topic, and that is knowing your benchmark fractions, especially knowing what is close to 1 and then what is close to 1/2. So being able to find half of something is a very good mental math skill so that you know what's about half. If you look here at 5/8, I know half of 8 is 4. So 5/8 is actually very close to 1/2. 8/10 is something that is almost one whole. I'm only two very small pieces away from the one whole, which is 10/10. So this one is almost 1. So if I'm estimating the sum of these two fractions, if this is almost 1/2, or if this is a little bit more than 1/2, and this is almost 1, the sum of these two fractions is about 1.5. Okay, so it's very important for you to know what is close to 1 and then what is close to 1/2. And when you get very good at these benchmark fractions, then you can go on to knowing what's close to 1/4 and then what's close to 1/10. Okay, so I'm going to go ahead and jump into the test review. You have the test review in front of you. If you do not, then you can check your email or ask your parents to check their email to find the message that I sent where I gave you the link to my Google Drive. And on my Google Drive, you can access this exact document. You can also access all of the notes that are organized in folders according to units. So definitely check that out. If you did not receive any of the emails, please let me know so that I can get you that information. So I know with the poor quality of this camera, these problems are very hard to see. So what I did was I just kind of rewrote them in shorthand to begin the test review over here on this paper. So please bear with me. I'm trying my best to be as clear as possible. If you guys have any questions, please feel free to comment on the YouTube live stream or on Google Classroom, and I'll be able to help you out then. So I'm just going to wheel over to my desk really quick. I see a comment right there, so I'm going to see who it is and what they need. All right, so the first question reads, 5 friends want to share 5/6 of the pizza equally. Which of these answer choices shows the amount of pizza that each friend will get? So you've got a series of addition problems. And what you've got to notice is in the problem, it says 5 friends want to share this much pizza. So what does 5/6 look like? Well, if we've got a pizza, then you can go ahead and just draw a picture of what that looks like. 5/6 is something that I can draw very quickly. Take a pizza, divide it into 6 pieces, and 5/6 is this piece, this piece, this piece, this piece, and this piece. Okay? So what I see in the answer choices is I've got a fraction being broken down into a sum. Okay, so if I've got 5/6 and I've got 5 friends, 5 pieces, 1, 2, 3, 4, 5. So if you've got 5 friends and 5 pieces to share, how many does everybody get? Well, this is friend number 1. They get that piece. Friend number 2 gets that piece. Friend number 3 gets that piece. friend number 4 gets that piece, and friend number 5 gets that piece. Okay? 5 friends, 5 pieces, everybody gets one. So if I use up all of the shaded pieces, then I know that I've shared the 5 6. So what does this one piece represent? Let's look at just one piece. One of these pieces represents what fraction of the whole pizza? We're looking at the unit fraction. If you don't know what unit fraction means, go ahead and look it up in your math notebook. But the word unit suggests what number of pieces are we talking about? It's just one. One out of how many? How many total pieces are there in this pizza? There's 6. Okay? They don't get to share all of them. They only get to share 5 of those pieces, but there are 6 slices in this pizza. Okay? So if the unit is 1/6, that means this piece is 1/6, this piece is 1/6, this piece is 1/6, this piece is 1/6, and this piece is 1/6. So if friend number 1 had 1/6 of the pizza, friend number 2 had 1/6 of the pizza, friend number 3 had 1/6 of the pizza, friend number 4 had 1/6 of the pizza, and friend number 5 had 1/6 of the pizza. That is the addition problem that represents how much they got to share. Okay? So, first friend, second friend, third friend, fourth friend, fifth friend. And the one that matches is answer choice B. So, you've got to be able to break down a fraction into a sum of its units. That's what skill we're looking at here. We're decomposing 5, 6 into smaller pieces. Okay, I'm going to give you a second to process that. Okay, so we have a few friends that are joining us in this live stream, so just wanted to answer their questions really quick. But let's go ahead and move on to number 2, about Flora and Jackson and Carly having their disagreement. So the picture is this. Flora says that the fraction shaded can be shown as 3/8 plus 4/8. Jackson says that it's actually 2/8 plus 5/8. Carly says it's 1/8 plus 7/8. So who of the 3 is not correct? So we're decomposing fractions again, showing the fractions as a sum of smaller fractions. We don't always have to break it down to its individual units. You can show it in other ways. So let's look. If I have 3 of those eighths, that's 1, 2, 3. This one, that's 3/8. Okay? And then I'm going to add 4/8. That is 1, 2, 3, 4. Okay, that's all of the pieces that were shaded. 1, 2, 3, 4, 5, 6, 7. Total of 7 pieces is shaded out of 8. Okay, so the fraction that's shaded is 7/8. So I can break it down to 3 pieces plus 4 pieces. Flora's is correct because her total is going to give me 7 pieces out of 8. Well, let's look at Jackson. Jackson says that it's 2 pieces plus 5 pieces. Let me grab a different color. Okay, so if Jackson says it's 2 pieces plus 5 pieces, let's see. There's 1, 2, and then let's see how many are left. 1, 2, 3, 4, 5. So 2 pieces, these 2 right here, plus these 5 pieces is also equal to 7/8. So Jackson is also correct. Before we jump to just choosing Carly, let's see what's wrong with her thinking. She says that 1/8 plus 7/8 is what this is. So let's look at it. Let's do 1/8, which is just this one piece right here. And then let's see if the rest of the shaded region is 7 pieces. 1, 2, 3, 4, 5, 6, 7. If I had added an additional 7 pieces, that would actually be all 8 pieces are shaded. This is 8/8. But that's not the same as what was shaded. What was shaded was only 7/8. So that means Carly is the one that is incorrect. Okay? So generally for decomposing fractions, you can take a fraction, try to draw a picture, and show different combinations that would give you that fraction right there. And in this case, it's 7/8. Okay, let's move on to number 3. Harper colored 36 of 60 pictures. Which of these fractions is not equivalent to the fraction of pictures that Harper colored? So if she colored 36 out of 60 pictures, how do I rewrite that as a fraction? 36 of 60? Well, there's a total of 60 pictures, and she colored 36 of them. So my fraction is 36, 36 60ths. Whoops, the focus is going crazy. All right, so the question is asking which of these fractions right here is not equivalent to 36 60ths. So what I've got to do is see if I can make these into an equivalent fraction that has a 60 in the denominator. Okay? Okay, so let's see if we can do this. What math do I have to do to get from 10 to 60? Do you know? What do I have to do to the 10 to make it a 60? I hope you said that you can multiply times 6. Okay, so 10 times 6 is 60. And we know from our process chart of finding equivalent fractions, whatever we do to the bottom, we also have to do to the top. So let's see here. If I multiply times 6 on the bottom, let's go ahead and multiply times 6 on the top. 6 times 6 is how much? It's 36. And look at that. That is equivalent. So this is not the one that we want. Let's look at 3/5. How do I get from 5 to 60? What do I have to multiply times 5 to get to 60? 5 times 12. So let's look at 3 times 12. What's 3 times 12? It's also 36. So 6/10, 3/5, both of those are equivalent to 36/60. But we're trying to find the one that's not, okay? So whenever we find one that doesn't work, that's our answer choice. So let's look here. 20 times what is going to get me 60? 20, 40, 60, that's 3 times 3. 8 times 3, because I've got to do the same thing at the top. 8 times 3 is how much? It's 24. Ooh, so right now I see a fraction that is not equivalent to 36/60. So let's just check the bottom one, just because we want to be sure for sure that C is our answer choice. So 30 times what is going to give me 60? 2. So I need to be able to multiply 18 times 2. 18 times 2 is, if you don't know, work it out. That's 16 plus 1 is 3. It's 36. So there is another fraction that is equivalent to 36/60. The only one that didn't work was answer choice C. Okay? Again, I have to apologize about the poor quality of the video. It's doing the best that it can. I'm probably going to have to see if I can get another camera set up soon in the classroom. But let's go ahead and go on. We've got this number line, and we have to figure out what's going on here. We started at 0, and then the arrow jumped to 6/10, and then it jumped again to 8/10. And the question is asking, which equation did Ryan represent on this number line? Okay, so the first task of a number line problem is to always do what? What should we do? I hope you said figure out what it's counting by. Okay, so we're trying to figure out what this number line is counting by. Let's look. If this is 6/10 and that's 8/10, there's only one empty hash mark in the middle, and then that's empty, and that's 1. So let me just kind of count to see how many take me out to here. 1, 2, 3, 4, 5, 6. Ooh, it's counting by, did you already know? It's counting by 1/10. So this is 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, that works. 7/10, that's 8/10, and this one is 9/10. And the next one is 10/10, or just simply 1 whole. So let's see what's going on here. It starts with 0, and then it jumps all the way to 6/10. And then it jumps how many more spaces to get to 8/10? 1/10, 2/10. So if we had 6/10 to begin with, and then we added an additional 2/10, where the arrow ends up is actually 8/10. And that one on your test review is answer choice B. Okay? Let's go to number 5. Clayton is making a pot of stew and a pot of soup. The stew recipe calls for 1/5 pounds of carrots. The soup recipe calls for 2/3 pounds of carrots. Davis thinks that he will need more than 1 pound of carrots to make both recipes. Is he correct? So, here we've got some fractions. This is a problem where knowing your benchmark fractions is going to be very helpful. And which benchmark fraction do we need to know very well? In your notes, knowing 1 and 1/2 is going to be very helpful. Okay? You can also draw a picture. You can draw 1/5, you can draw 2/3. So let's go ahead and do that. So the first one, 5ths. And the next one, 2/3. Okay? So 1/5, 2/3. This is the total number of carrots, the total amount of carrots that Clayton is going to need to make both recipes. Okay? So let's look at this. I can't simply add all of those pieces together. I can't just say 3 pieces because the denominators are not the same. So that means the portion sizes are very different. So using what I know about benchmark fractions, I can kind of figure this out. So 2/3 I see is very close to 1. It's 1 piece away from being a whole pound, okay? And now let's look at the size of the pieces here. 1/5 is a lot smaller than 1/3. The piece that is 1/5 is smaller than 1/3. And I have one of these pieces shaded. So if I took this piece that is smaller than 1/3 to cover up here and just kind of add it in, would I make it completely to 1 pound? The answer is no, because 1/3 is a lot bigger than what this piece actually is. So when I take 1/5 and 2/3, it's actually something that is less than 1. But Davis says that I would need more than 1 pound of carrots. Is he correct? Davis is not correct. So my advice to you is, as far as these fractions go, when you have to add fractions that have different denominators, draw them and think about what is close to 1 and what is close to 1/2. And that's going to help you a lot more than to try to rack your brains out doing math that we haven't actually practiced. Okay, so the actual addition of fractions with different denominators is a skill that you're going to be able to do next year. But don't waste your time because you can do it by just drawing pictures and estimating. Okay, so this is an estimating kind of problem. So you can do it by drawing pictures and using your reasoning to figure this out. All right, so number 6, let's look at this number line right here. 35 is all the way over here. And then we skip all the way over here and we have 37 and 3/4. And then the very next hash mark is 38. So our first task for a number line problem is always to do what? Always figure out what the number line is counting by. So this number line, here you've got two that are very close to each other. 37 and 3/4 and then 38. The next whole number over here. So what is this number line counting by? Each little mark is 1/4. So the question is asking you to figure out which of these points is 36 and 1/4. Which of those points represents 36 and 1/4? So here I've got 35. How many fourths do I need to add to 35 to get to the next whole number, which is 36? Well, if this is 35 and 1/4, 35 and 2/4, 35 and 3/4, 35 and 4/4. 4/4 is also another 1, so 35 and another 1. This is 36. S is 36. But the question is not asking for what is 36. It's asking for 36 and 1/4. So what is 1/4 more than 36? It's this point right here, T. So the answer to that question is T, because T is the one that represents 36 and 1/4. So on a number line, just remember you have to figure out what it's counting by first and then label the missing pieces. If you jump into it without figuring out what it's counting by, you're going to run into a lot of trouble. And make sure you're labeling things so that you're not making any mistakes in your reasoning. So let's go on to number 7 and 8. Numbers 7 and 8 are tables with an equation. So your equation is this. The value of square is being multiplied times 25 to give you the value of circle. So in these tables here, you have lots of values that can be used for square. And then you're supposed to get out this value right here that represents the circle. So when you have a problem like this, where you see an equation in 4 different tables, it's going to ask you which of these tables has data that will match that equation right there. You definitely need to check all of the values to make sure that everything works. It has to work for every value in the table in order for it to be the table that matches that equation. So let's look at A really quick. A has these values for square. I have 3, I have 5, I have 7, I have 8. Okay? So it's saying that I can take all of these and multiply times 25 to get the value that is circle. 3 times 25 is 75. 5 times 25 is 125. 7 times 25 is how much? It's 200, 175. And then 8 times 25 is 200. So I'm going to go through and I'm going to check to make sure that all of this is correct. 3 times 25 is 75. That works. 5 times 25 is 125. That works. 7 times 25 is 175. That one works. 8 times 25, that's 200. That one works. And because everything works, I'm going to tentatively say that A is the answer choice. Well, let's check some of the other ones. B. What are all the values of square? 3, 50, 7, and 9. Times 25, times 25, times 25, times 25. 3 times 25 is 75. 50 times 25 is 125 with a 0 at the end, 1,250. 7 times 25 is 175. 9 times 25, that is 225. And right away I can see that these answer choices don't match up at all. So B cannot be the correct one. So let's look at C. Oh, I'm sorry. I just noticed a mistake that I made. This is not 8. That's 9. I apologize. I thought something was weird. But that is supposed to be 9. I just copied it wrong. I apologize. And so because that doesn't match, A is not the answer choice. I apologize about that. Let's look here again at the next one, answer choice C. All the values of square, 3, 5, 7, 9. I'm going to multiply everything times 25. Oh, that's so blurry. This one is 75, 125, 175, and 225. Do these values match what is under the circle? 25, 50. Oh, that doesn't match. C is not the one. Let's try D. Square, 3, 5, 7, and 9. I can take all of these and multiply times 25. Again, 75, 125, 175, 225. This one, 75, that one checks out. 125, that checks out. 175, that one checks out. And 225. This is the one. D is the correct answer choice because all of these values of square, when you multiply times 25, you get all of these values of circle. And I'm very sorry about that. I didn't mean to copy it down wrong. I just wanted to make it more clear on this sheet because this sheet right here is impossible to read. So let's go on and do number 8, hoping maybe I did not copy anything down wrong. Okay, so number 8, you have a value of circle divided by 12, and you get the value of the box. Okay, so we're going to take all of the values of circle, 84, 60, 36, and 12. And I'm going to divide all of those by 12. Okay, 84 divided by 12 is 7. 60 divided by 12 is 5. 36 divided by 12 is 3. 12 divided by 12 is 1. These should be the value of box, but that doesn't match at all. So this table is not the one. But this one right here has all of the values that I just calculated, and the value of box does match. So this is the one that looks like it's going to work. Well, let's double check these right here. if I have the values of circle, which are 1, 3, 5, and 7, and I divide all those by 12, 1 divided by 12 is not 12. That's 1 times 12, okay? So since the operation doesn't work, 3 cannot be divided by 12. Not to get a whole number, 5 divided by 12, that doesn't really work. 7 divided by 12, not without getting fraction answers. So definitely this one right here is not one that works. You need to be very careful. Sometimes they'll switch up the values just to see if you're paying attention, okay? This is the one where if I take the value of this and divide by 12, I get these answers. And let's look at this. 96 divided by 12 is definitely not 48, okay? So this one is not it. The only one that works is answer choice C, which is this table right here, okay? All right. So moving right along. Again, on the test, there's not going to be very much dealing with equations. Mostly, you're just going to have to be able to read a problem and build an equation from it. Okay? Number 9. Which of these sums is going to be closest to 1? And then which of these sums is closest to 1/2? So here we go again with our benchmark fractions. You have to know what is close to 1 and what is close to 1/2. So let's look at this reasoning here. Something divided by into 8 pieces and then something divided into 10 pieces. These are 2 very small pieces. They're not that close to either 1 or 1/2. So for right now, I'm just going to say this one is neither. 3/5. 3/5 is about, it's a little bit more than a half because half of 5 is around 2 or 3. And then 10, if I have 8 of the 10 pieces, that's almost 1. So if I have 1/2 plus 1, this is close to 1.5. Okay, that's too much. That answers neither of my questions. So now let's look at this one. 3/8. 3/8, half of 8 is 4. So this is almost 1/2. It is a little bit less than 1/2. And then I'm adding 1/4. This one is probably going to get me somewhere very close to 1/2. So 1/4 is just, it's about half of a half. So if I take something that's less than a half and I add a little bit more, I might be a little bit more than 1/2, but I'll be very close. And let's look at this one. 4/10. Half of 10 is 5. Well, this is almost 5. This is about 1/2. And 1/2 plus 1/2, this is around 1. So this one is closest to 1. And this one is closest to 1/2. You have to be able to reason your way through it, knowing what is close to 1 and what is close to 1/2. Knowing those benchmark fractions is definitely going to help you a lot with a problem like this. Okay? Let's go on to the next one. Here we have 4 sets of fractions that are being compared, and it's asking you which of the following comparisons is true. Okay, so let's look in our notes about comparing fractions. This page right here, all of our guiding questions, the first question that we need to ask ourselves is, do those fractions have common denominators? So let's look. Do these fractions have common denominators? No. So we need to make them have common denominators. I know that I can take this 15 and make it into a fraction that will match that common denominator right there. Okay? If I want to, I can look at my 5s. 5, 10, 15. I'm already there. 5 times 3 gives me 15. So if I multiply top and bottom times 3, then it will give me an equivalent fraction that matches the denominator on the other side. So 3 times 1 is 3. So 3/15. Is 3/15 greater than 8/15? If I have 3 of those pieces, is that more than having 8 of those pieces? No. So this one doesn't work. Let's look at this one. 3/12, 1/4. Oh, I know 4 can be changed to match this denominator right here. Let me look at my facts. 4, 8, 12. Ooh, there it is. I know I can change this denominator to have something that has a 12 on the bottom. 4 times what is 12? 4 times 3. And whatever you do on the bottom, you have to do the same thing on the top. 1 times 3 is 3. 3/12. Hey, that's the same as this side. Well, if they're the same, then it should be an equal sign, but that's not an equal sign. So that one is not the one we're looking for. Next, 1/2 and 9/12. Oh, okay, well, I know I can take this 2 and change it to something to match that 12, but let's look. 2, 4, 6, 8, 10, 12. There it is. 2 times what is going to get me 12? 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, 2 times 6. So if I multiply times 6 on the bottom, I also have to multiply times 6 on the top. 1 times 6 is 6. 6/12. Is that less than 9/12? Ooh, looks good. But let's double check just to be sure. 3/8, 10/24. I know the 8 can become 24. 8, 16, 24. Oh, times 3. 8 times 3 is 24. So I need to do the same thing at the top. 3 times 3 is 9. Is 9/24 more than 10/24? No. So our answer is C. So you can see the amount of work that is required in a problem like this. You can't just look at it and choose. You have to actually work through each of the answer choices to figure out which one is true and which one is not. Okay? So this is the work that is required on problems like this. Equivalent fractions, comparison fractions, they require a lot of work. Let's look at number 11. You get a new job that pays $5 an hour. If you work 12 hours in week 1 and 7 hours in the next week, write 2 equations that show you how much money, or M, you earned in all. So it wants you to show an equation in 2 ways. So we need to be able to identify 2 different equations that will give you the same answer. Well, let's look at how we can approach this. If you know you worked $5 an hour What do you have to do to figure out how much money you're going to earn altogether? So you know how much you are going to get paid. That's called your rate. For every hour, you earn $5. You work this hour, you get $5. You work the next hour, you get $5. You work the next hour, you get $5. You work the next hour, you get $5. So what kind of problem are we working with here? It's a multiplication problem. So, however many hours you worked times how much you get paid for every hour, that's going to give you the total amount of money you are going to be paid. So, let's use this concept. How many hours did I work times the number of dollars I get paid for every hour? How much is that altogether? So how do I figure out the number of hours? It tells me right here. So I worked 2 weeks. So I could find the total of hours times my rate, and that would get me this. But I have to be able to show this in another way. So aside from adding up my hours ahead of time, why don't I figure out how much was week 1? In week 1, I worked 12 hours and I got this much money, okay? And then in week 2, I worked 7 hours and earned this much money. If I add week 1 and week 2 together, that would give me the total amount of money that I earned. So knowing how to write an equation 2 different ways, you've got to be able to see that there is more than one way to solve this problem. Are they both going to work? Which one might not work? And we're on the last one, number 12. Number 12 says use multiplication and division to find fractions that are equivalent to 3/9. So, equivalent fractions, whatever math you do on the top, you have to do the same thing on the bottom. So, we need to choose the same number on top and bottom to multiply. Because we're looking for something we can multiply that's an equivalent to 1 so that we don't change the value of the fraction at all. So let's see here. What do you want to choose? We can choose anything you want except for 1. If you choose 1 on top and 1 on bottom, in both cases, you're not finding an equivalent fraction at all. It's just the same fraction. So you did meaningless work. All right, well, let's just choose 2 then. This 2 is just as easy. As long as it's the same on top and bottom, it doesn't matter. You can choose 100 for all I care. But 3 times 2, that's 6. 9 times 2, that's 18. So 6/18 is equivalent to 3/9. Well, now let's divide. What can I divide top and bottom by? If you don't know, then you could think of the factors. What are the factors of 3? It's just 1 and 3. Well, what are the factors of 9? It's 1 and 9. How about 2? Does 2 go into 9? No. How about 3? 3 goes into 9. And then it looped back onto itself. So what number is the same on both sides? It's 3. So let's divide top and bottom by 3 because we know that's going to work. 3 divided by 3 is 1. 9 divided by 3 is 3. So 1/3 is another equivalent fraction. We found an equivalent fraction by multiplying and by dividing. You should be able to go both ways. So that takes us through the entire test review. What I was trying to do before I logged on was to create shorter videos, but I'm having some trouble with my iPad. It wasn't working the way that I wanted to, and it's freezing and things like that. So I will try to do that when I get home. But if you have any questions or you want to see any of these problems being worked out again, when the live feed posts to my channel, you can re-watch this video as many times as you want. And then you can ask your mom to make up new problems for you to work out, so that you can get as much practice as you want. We are going to continue our practice in class this week, and that way we can be really ready for everything that is expected of us on Thursday. So good luck working through this test review by yourself. You have this video as a resource, all of my notes on Google Drive as a resource as well, and you can come and see me before school or during lunch. So I will see you all tomorrow. Have a great rest of your day.